Hello, everybody. It's Tyler with 3D Printing Basics. If you guys were interested in getting every single episode of this podcast, 3D Printing Basics, ad-free and a week early, and also getting exclusive perks such as exclusive episodes that only you can listen to and more, then subscribe on Patreon. My link will be down below. I would really appreciate it if you guys would consider supporting me. All the support I've already received has meant the world to me, so thank you guys so much. If not, no worries. Continue to consume these episodes for free, and I appreciate you listening regardless. So thank you guys very much for listening, and I hope you enjoyed today's episode. Hello, and welcome back to 3D Printing Basics. This is episode number 104, and in this week's episode, we are going to be talking about 3D printing tolerances. I put up a poll on my Patreon page and asked my subscribers to vote on a couple different topic ideas, and this is the one that they settled on. So we are going to be talking about tolerances in 3D printing when you're trying to mate parts together or have them friction fit, press fit, loose fit. We're going to be talking about all of those things and kind of just the overall aspect of tolerances in 3D printing, how to design for them, how to kind of anticipate what's going to happen with them depending on what you're doing, what printer you're using, etc., etc. So before we get started, I just wanted to mention again the Instagram, the 3D Printing Basics Instagram, that's up and running. Once we get to 1,000 followers, I'm going to be giving away a 3D printer, so that's super exciting. So make sure you head on over to the Instagram and give me a follow. The link will be in the description below, and I really appreciate everybody listening to the podcast. It means the world to me. So with that being said, let's jump right into the episode. So let's talk about what tolerance means. And so tolerance is going to be the intentional gap or allowance between two parts, because when you're printing a part, or not even just printing a part, when you're making two parts fit together, whether it be CNC machining, whether you're making out of wood, metal, plastic, injection molding, 3D printing, laser cutting, anything, the hole cannot be the same size as the mating part. If you're making a 10 millimeter hole, then the mating part cannot be 10 millimeters. It needs to be a little bit smaller in order so that it can actually fit inside the 10 millimeter hole. And that is called tolerance. Tolerance is going to be how small or how much smaller you make that mating part so that it can fit into the hole. And depending on how small you make it, how much tolerance you give it, that is going to affect the fit. You can have a looser fit, you can have a tighter fit, friction fit, press fit, all of that good stuff. So that is kind of what we're going to be diving into. But the key idea here is that perfect dimensions on screen, they don't equal perfect parts in real life, because if you have the perfect dimensions on your computer or in your CAD design, then that usually means that you're going to have issues, especially with 3D printing, because 3D printers, while they are accurate, they do have some issues in terms of creating perfect geometrical parts that we are going to be discussing today. So I want to talk about why 3D printers aren't perfectly accurate, kind of touching more on that topic. And while 3D printers, they are really good for manufacturing parts, they can churn out consistent, reliable, and accurate parts. When it comes to the mating parts, when you have one, say you have a peg going into a circular hole, these two 3D printed parts, they aren't perfectly accurate. They have some issues with 3D printers that make it hard to create these perfectly accurate, super tight tolerance mating parts. You got things like slight over or under extrusion that can happen. You can have layer squish, which can affect the overall layout of your parts. It changes the shape of them. Filament inconsistencies, machine tolerances themselves. They can, if you have a machine that has loose tolerances, those can compound, and then when you want to print a 10 millimeter hole, it can actually turn out to be 10.1 millimeters, 10.2 millimeters. And then that, of course, when you have a 0.1 or 0.2 millimeter tolerance, that's going to be a huge issue, because you effectively just doubled your tolerance and you're going to have a super loose fit, which in most cases is not exactly what you want. You also have thermal expansion and contraction. When you're printing printing melted plastic on a heated plate and then everything cools down, that could cause it to shrink a little bit, versus when it's coming hot out of the nozzle, it expands a little bit, and then that can affect the print. So the machine thinks it's printing a 10 millimeter peg, but when everything cools down, it actually shrinks down to about 9.8 millimeters. And if you're printing a hole with that, then that causes it to be too small, and then you have issues where it doesn't fit because the hole itself is too tight. So that is why 3D printers aren't the most accurate machines, especially when it comes to mating tolerances, but you can absolutely design around that. once you do a test fit, you can prototype some things, and you can make, for example, you can make the mating piece a little bigger, maybe a little smaller. You can make the hole that it's supposed to fit in a little bigger, maybe a little smaller. And you can make these adjustments really easily. That's one of the good things about 3D printing, is even if you're mass producing something, it's really easy to make changes and sort of adjust on the fly. So it's definitely something that is very nice and helpful. Now that we know kind of what to look for in 3D printers, let's talk about the types of fits that we are going to be gunning for. There's two of the main fits when it comes to tolerances. We're going to be doing the clearance fit or the loose fit, and this is when we want parts to kind of just fit together. We don't need them to be super tight. Obviously, we don't want them to be shaking around in there super loose, but we want them to be tight, but not any kind of force to be pressed in or anything like that. And that typical gap is going to be usually 0.2 to 0.4 millimeters when you're making parts like that. So a clearance fit, you're definitely going to want to be within the 0.2 to 0.4 millimeter section. That is just going to help you create that nice looser fit. I don't know what else to say besides loose, but it's not loose. It's still a tight fit, but you're not going to have to actually use any kind of force because there's no friction when the two parts are sliding together. The next fit that you have is going to be a press fit, and this fit is, if you get it exactly right, it's going to mean that the parts fit together really nicely. They hold together nicely, meaning they don't fall out if you turn it upside down or anything like that. The parts, they snap or they press together, and just overall it is a very clean, very nice fit. And the typical gap that you're going to want to have here, depending on your printer and depending on the sizes that you're working with, is 0.05 millimeters to 0.2 millimeters. And sometimes you're going to have interference here. This is definitely one of the harder fits to dial in. It usually takes a couple tries. You're kind of going to have to feel out your printer, feel out the tolerances that it is able to do, and then adjust from there. But once you get it dialed in, you can definitely churn out repeatable, tight fits that hold together but don't require like a machine to be able to put together. And then if you turn them upside down or if you try to pull them apart, it takes some actual force instead of them just kind of falling out on their own or due to gravity. The next fit that we're going to have, which is definitely something that doesn't happen too often, especially in 3D printing with my experience, that is going to be the interference fit. And that is going to be something that is really, really tight, and you oftentimes need tools in order to get things to fit together. Normally, these are going to be fits that are permanent or at least semi-permanent, meaning you're not going to take it on and off very often. Usually you put it together once and then you're kind of done with it. And this isn't a fit I really love to do, especially with plastic. You know, at the end of the day, we have some really strong plastics. You know, we have our carbon fiber nylons, the PEEK, the engineering filaments. We have things like that. But at the end of the day, it is plastic. And if you try to force something together that just isn't going to go together, the plastic is going to crack. It's going to shatter, fall apart. It's going to fail. And so that's why I almost never use interference fits when it comes to 3D printing. Just the plastic, when you're trying to force two plastic parts together like that, especially when you're using metal tools that are stronger than the plastic itself, then you can definitely run into some issues there. But that fit is usually going to be 0.01 millimeters to 0.05 millimeters. So kind of running over everything and where we were with the interference fit, very tight. We're usually not going to use this a whole lot. You want to be 0.01 millimeters to 0.05 millimeters. And then the sort of optimal fit, the press fit that you're going to want to be using, most of the time when you're 3D printing, it's definitely if you get it dialed in, it's a helpful, nice fit, especially with prototyping and things like that. You're going to want to be 0.05 millimeters to 0.2 millimeters. And then the loose fit, just something that slides together on and off really easily with no extra force or tooling or anything like that. You're going to want to be at 0.2 millimeters to 0.4 millimeters. And those are kind of the general rules of thumb to follow. Sometimes you're going to need to be a little bit greater. Sometimes you're going to be a little bit smaller depending on what fit and what 3D printer you have. That is just a general rule of thumb that I like to follow before dialing it in on my own actual printer. And that's definitely something to keep in mind, is that everybody's 3D printer, whether you have the same machine, different machine, depending on environment, depending on how much it's used, how many hours are on it, it's going to print differently. So that's definitely something to keep in mind when you're 3D printing, is that every situation is different and you're going to have to dial in your own settings and your own process yourself in order to get the result that you are most happy with. So that is definitely something to consider when we're doing this and just in 3D printing overall. Another thing that I did want to mention before we wrap this episode up is going to be the horizontal versus vertical tolerances. As we know with 3D printing, especially when we're printing something like circular, so for example, if we're using a dowel fit, when we want a circular hole and then we got the circular dowel that we want to fit right in there, depending on which dimension you're printing it on, it's going to affect the size of it differently. So if you're printing on the X and Y, where the circle is pointing straight up or the dowel is pointing straight up, that is going to be your best bet for creating the circular tolerances, because the circles, they print really well because it's easy for the machine to go around in a circle. But if you're printing it on the Z tolerances, where the circle or the dowel fit is flat, that is going to affect your part. As we know with the layers and just with the overall mechanics of 3D printing, if you're trying to print a circular object flat on the bed so that it's not pointing straight up and down, it is not going to be circular. Pretty much no matter what you do, you're going to have to be printing in micron layers. It's going to take you days to finish, but overall that is not going to turn out very well. And so we know that it is not going to be a circular fit, and so you either need to compensate and print the mating part on the same level and kind of adjust your tolerances to find the good fit for you, or you're going to have to flip the whole part so that it's printing up and down. But that is definitely something that I wanted to mention so that we make sure that we are on the same page there, that not only does the tolerance and the fit that you're using matter, but also the orientation matters. If you're printing straight up and down, you're printing those straight perfect circular holes that 3D printing is good at printing, then you don't need to worry as much. But if you have an orientation where you have to print the circular opening flat or anything like that, even with rectangular fittings, and you're going to have to use supports because it can't bridge over open air, that is definitely something to consider as well. That is going to affect the overall geometry of the fit. And so that is why it's definitely very important that you test your parts before printing the final one, especially if you're printing something like for a customer. You really need to test your fits. Whenever I'm printing something for a customer that requires mating parts like that, I almost always check my fits, and that is something that actually almost burned me a little bit on my last project. I was printing a giant cityscape. We're talking, it probably ended up being like 4 feet by 4 feet, and so we had slats on the bottom with dowel holes so that it could tie all these sort of puzzle pieces together, because I couldn't print the whole 4x4 piece at once. So 4 feet by 4 feet, we couldn't print all of that at once, and so we had to split it up in different pieces, and then we wanted to tie it together with these slats going diagonally across everything with the dowel holes that fit. And so I created the dowels. I printed the first slat to test, and the holes, despite using the connector feature that Bamboo Studio has, where it creates your own dowels and fit for you, it was actually too big. It didn't fit. So I had to go and adjust each and every one a little bit smaller so that it would slide into the puzzle pieces on top, essentially, so that these slats were laying underneath, and then they connected everything together. And once I kind of fixed the fit there, made it a little bit smaller, I didn't need it to be a super tight fit, so I had it a little bit on the looser side just to make sure that it would go in, and then also give those puzzle pieces a little bit to move around so that they could adjust them as they please before gluing them all together. And that ended up working out really well, especially once I got the slat tested. I printed one, and then I tested it, and it fit well in all the holes, and so then I was able to print the rest of them. And I believe there's about 60 of these diagonal slats to kind of tie everything together. So that was definitely a real world example of designing for tolerances for me, and a good lesson to not trust the slicing software itself. Even though I've had success with it in the past, it doesn't mean it's always going to go well. And that was probably a mix of the printer that I had. I was using a Solvo printer that wasn't as accurate as maybe a Bamboo printer, and also the type of filament I was using. I was using a PETG that was on the cheaper side. It was still a good quality filament, but it was a little bit on the cheaper side, and so there was probably a little bit of extrusion errors there, maybe a little bit of over extrusion that caused the dowels themselves to be too tight and not go in at all. But that is definitely something to consider when you're designing for tolerances. And with that being said, that's all I have for you guys today. I hope you guys enjoyed the episode and were able to understand a little bit more about designing for tolerances in 3D printing, and kind of what to look for and how to understand the best way to go about it so that you're getting the desired fit that you want. Just wanted to let you guys know, subscribe on my Patreon if you want to support me and get every episode a week early, or also with the exclusive monthly bonus episodes. And then also follow me on Instagram. We are doing the printer giveaway once we hit 1,000 followers. So thank you guys so much for listening to this episode, and I'll talk to you guys next time.